the next video tutorial where we talk about power. And there's another video that you can look at that talks about how to do power in R, but here we're going to do it via simulation because this is often how you have to do it. You may not like doing it this way, but this is the way that lots of people can calculate power, and it works for just about everything. And actually, I prefer to do it this way than other ways. This particular video, we're just going to talk about using what power is and talk about it from a very abstract perspective. In the next video, we'll actually talk about how to do this via randomization test type idea. So power can be calculated in a similar manner as a randomization test. We need to know the decision rule for the null hypothesis because that's what we're trying to find out, how often we reject the null when we should. So we need to know that. We need to see if we can vary the effect size and see how often the results become significant. We can vary the sample size to see how often the results become significant. So these are two things that people often do so that they can examine how much power they actually have given their data or something they plan. So often you will hear people say, how big of a sample size do I need? And you say, well, depends on how big of an effect you need. Or it could be, how big of an effect can I detect given the sample size? So these two go together, and you need to know both, otherwise it isn't going to work out well. Okay, and you can also do what I call post hoc power, which is I had a test, didn't have anything significant, I'm really depressed. How much power did I have? Was something really there? And this is actually useful because if you find something not significant, but you had an incredible amount of power, then that means that it's probably not there. The null hypothesis actually has some evidence towards it because if there was a difference, you would have detected it. All right, so let's go rolling here. All right, here's a review of power. Power is 1 minus beta, which is the probability that you reject H naught when the alternative is true. So here I give this little picture here, and it says mu naught is equal to 0 and mu A is equal to 0, which is here our null hypothesis. And our rejection region is this shaded area, right? So the red line here says if we saw something bigger than this, we would reject. And I've just have this as a one-sided test right now because it makes it easy. So here, what we're interested in is we can't even tell these two distributions apart, okay? But if we just change the difference by 1, you notice the second distribution shows up here. You can clearly see it. And the red line is still there saying this is where we would reject, but this area under the curve here is growing larger. If you go back here, this is actually 0.05 for what I'm doing here. That's the area under that curve. But when I do this, it goes up. Notice I have more area that's in green, which means that the probability or power that I reject is higher given this difference. And I can keep going here, make it 2, and you can see that it keeps getting more and more and more green. This is the power of the test, is this probability. And so here, this is really useful because as the distributions move farther apart, meaning the means move farther apart, the power goes up. And then that's exactly what you would expect, right? I mean, come on, think about it. If they're really different and the differences keep getting bigger and bigger, it should be that I'm more likely to find it. Okay, so often what people do is they'll take this series of pictures that I had before, and they'll plot it across the possible differences. So you get this thing called a power curve. Down here, this is going to be at 0.05 because it always is. If your power or your calculations are correct, you should end up with 0.05 because that's how often you should reject when there's no difference. Okay, and then as the difference here, delta, increases, notice it comes up and it levels off at 1, which we would expect because power is a probability and it can't be bigger than 1. But you can get a sense of how big of a difference you can expect to see with what power. So let's suppose I say, well, I want to find a difference of 1. Well, if I come up here and look, the power is almost 100%. Okay. If I say, well, I'm interested in having a power of 80%, I can trace this back and say, well, that's about a 0.5. That's about what I would expect my difference to be able to find 80% of the time, and so on. So you can read this both directions. You can also do this in terms of sample size. So here you specify the difference. The other one here, the sample size is always the same. Here we're going to vary the sample size, but the difference is equal to 1, and you get this picture. And notice that it doesn't immediately start at 0.05 because I already have a difference in it. And here's my sample size as it increases across here, and you can see the higher the sample size, the higher my power becomes. All right, so here's how you can do this in R without doing any sort of randomization type test. Okay, so you can use a 1 or 2 sample t-test on means, and there's a function in there called power.t-test. And you put the stuff in it, and it spits out the power. You can do this for 2 sample test on proportions on power.prop.test, and you can do this for one-way ANOVA on test on means on power.ANOVA.test. So you can look up what they say how to do them in the documentation. I have videos on the first 2. I don't think I have a video on the third one. But you can go and find them and see how to calculate these. But this is all that's really canned, okay? Because these have analytical solutions. So what if we just did something slightly more complicated and I said, here's simple linear regression. Here's our problem. How do we calculate power for this? Because it's not canned. And we're going to talk about that in the next video, is exactly how would we do this, okay? So keep on track here and stay tuned, and we'll jump to the next video and look at that.